Section 5.4 exercises. Problem 1. We're given the coordinates of point P on the unit circle. See, here's the equation of the unit circles. So there's point P, which is on that circle. Find the values of these 6 trigonometric functions. Okay, very easy. When you have the x and y coordinate given, and when you're on the unit circle, you do not need the right triangle definitions of the trig functions. The cosine of the angle t is simply given by the x value. So write down the answer, √3/2. The sine of the angle t, when you're on the unit circle, is given by the y coordinate of point P, so write down that answer, 1/2. And the tangent of angle t is given by the y coordinate divided by the x coordinate. That one will take a little bit of work, so we have 1/2 divided by √3/2. So we simplify that, 1/2 times the reciprocal, 2/√3. So let's come down here. Tangent of t is 1/√3. Now rationalize that, multiplying by √3/√3, and we finally have our tangent value of √3/3. Once you get those, you get the other 3 for free. So the secant of t is the reciprocal of the cosine, so that'll be 2/√3. Rationalized, 2√3/3. The cosecant of t is the reciprocal of the y, or the sine, so that's reciprocal of 1/2, or 2/1, or 2. And the cotangent of angle t is the reciprocal of the tangent. Reciprocate this one so you don't have to re-rationalize. And we get simply √3. And those are the 6 trig values of angle t. Problem 2. The range of the cosine function is all real numbers, -infinity to +infinity. So there is a number t in the domain. All right, let's take a look at the unit circle here. In trig, you draw pictures. This coordinate here for the angle of 0 or 2 pi is 1, 0. This angle for pi/2 has coordinate 0, 1. Here for 180-degree rotation, or pi, coordinates are -1, 0. And here at 3 pi/2 is the coordinates 0, -1. Now, cosine always tracks the x-coordinate of the point going around the circle. So take a look at the x-coordinate is 1, and then it decreases to 0, and then it decreases more to -1, then it increases back to 0, and keeps increasing back to 1. So the cosine of the angle is trapped between -1, and it can reach -1, so equal, and it can reach as much as +1. So the range, as you can now see, is the closed interval -1 to +1. So the given statement there is completely false. Work the problem through. Let's take a look at problem number 3. We're asked to find cosine of -60 degrees by using even or odd properties to get the exact value. Okay, so let's get the even odd properties here listed. The cosine function is an even function, and that means that the cosine of the negative angle is equal to the cosine of the positive angle. That's what it means to be an even function. And why that's true is that a positive angle is rotated this way, a negative angle is rotated this way. But cosine tracks the x-coordinate. So an x-coordinate at a point there, and the x-coordinate at the same angle, just the negative angle rotates to quadrant 4, will have the exact same x value. The y value will be negative in that quadrant, but the x value remains the same, and that's why the cosine is an even function. So for us, the cosine of -60 degrees is equal to the cosine of +60 degrees. Using our right triangle, we get 1/2. So So our right triangle here that I'm using, 60 degrees, 30 degrees here, 2 root 3, 1. Cosine is adjacent over hypotenuse. Use even and odd properties to find the exact value of the tangent. Tangent function is an odd property. Odd property means that tangent of the negative angle works out to be the same answer but the opposite sign, so the negative of the tangent of the positive angle. That means odd property. So we're asked to find the tangent of negative pi over 6. Okay? So the tangent of negative t is the opposite of tangent of positive t. Using our same triangle as above, but this time working from our 30-degree angle. See, if we work from our 30-degree angle, then we'll have tangent is the y over the x. So working through this angle here, 1 divided by root 3 with a minus sign in front. So minus sign, y, 1, x, root 3. So if we rationalize that, we get minus root 3 over 3, and that's the tangent of negative pi over 6. Use periodic properties to find the exact value of cosine 405 degrees. Okay, periodic property means that for the cosine and the sine, if we take the given angle and we add or subtract an entire rotation, we get the very same point as though we did not rotate an additional 360. So that's equal to the cosine of t. Adding or subtracting full rotations does nothing to the value of the cosine, since it brings you back to the very same point. Okay, that's what means periodic property. So for us, we have to think about this. 405 degrees can be written as 45 degrees plus a full rotation. And that full rotation of 360 brings us right back to the very same point. So that's the same thing as the cosine of 45 degrees. And using our special right triangles, our 45, 45, 90 triangle, we get the cosine to be root 2 over 2. Use periodic properties to find the exact value of the sine, 7 pi over 3. Okay? Sine, period of the sine function is 2 pi, just like the cosine. So our periodic property for sine would look like this. The angle plus a multiple rotation is just equal to the sine of the given angle. That addition of full rotation here brings you back to the same spot, and so the value of the sine function will be the same. So now we got to think a little bit. We've got sine of 7 pi over 3. And we got to write this so that it's an angle plus a full rotation. So let's see here. Let's look at 2 pi and write it with the denominator of 3. That'll be 6 pi over 3. Now you can see that we have 7 pi over 3. So it's a full rotation of 6 pi over 3 plus a little bit more. So the sine of 7 pi over 3 will be 1 pi over 3 plus 6 pi over 3. There's the addition of a full rotation of 2 pi, which does not matter since the sine function has period 2 pi, and we still get the sine of pi over 3. And so we appeal to our right triangle, and we get the opposite over the hypotenuse, and that'll be root 3 over 2. And that's how you get the sine of 7 pi over 3 using periodic properties. Okay, let's go on to, there are no more problems. We are done with section 5.4 exercises.